To go over the notes from the first lesson in chapter 3. So this whole unit is on functions. So we're going to first talk a little bit about what a function is. Hopefully this will feel like a review in terms of the work that you've done in algebra. And then we'll talk a little bit about function notation and especially what that looks like when you're asked to evaluate functions, whether you're given the actual equation of the function or you're given a graph of the function. All right, so here are the objectives that we're going to focus on today. So this first slide is looking at what a function is, all right? And the idea here is that if you have a relation, which is just a list of x values and a list of y values, anything can be a relation. But to go that step farther to be a function, we need to make sure that each possible input value leads to only exactly one output value. And there's a couple ways to check this. We'll look at it, how to check it when you're given a table of values, and then the same when you're given the graphical version of the function. Hopefully you remember the words domain and range. Not as important in today's lesson, but in the next lesson, we'll be talking about how to find and how to write the domain and range of functions. All right. Function notation just refers to that f of x, so f parentheses, then x. And then we don't say f times x, we say f of x. All right, so let's look at a table, and we'll look to see if any of these relations are functions. So the way you do this in terms of if you're given a table of values is you always look to see if you have a repeat in the input values, right? So remember, these input values are your x's. So if any of your x's repeat values with different outputs, that would mean that it's going to be a relation. It's not going to be a function. All right, so in this case, when I see an input of 2, 5, and 8, those are all different, so this will be a function. Table 7, same thing. I see 3 different input values, so this will also be a function. Now, what might mess up students when they do table 7 is you should notice that we do have a repeat in the outputs. That's okay. If your outputs repeat, that's fine, as long as your inputs do not repeat. All right, and then you can see finally in table 8, we do have a repeat here. We're using 5 twice in these inputs, so this is going to be a relation, not enough to move to a function. Okay, let's do some evaluating when you're given the actual function written out. In this case, we have a quadratic function, p squared. So I'm going to evaluate this with my notation at 4, which just means that says wherever I see p, I'm going to replace it with parentheses and that number 4. All right, so 4 squared is 16. 2 times 4 is 8. So that's going to be 24. So h of 4 is 24. So that means when I look at this function and plug in 4 for p, my output value, h of p, h of 4 will be 24. So that even though this is p and h, right, the idea is that like this is your x, and then what you get at the end is your output of y. Okay. Let's do finding some values from a graph. Now, one little note here after we do that is we're going to look at what would make a function one-to-one. So the way I kind of viewed it when I was in high school was, well, okay, when you're given values, whether it's the equation, whether it's a table, whether it's a graph, you can always say it's a relation. You're never wrong to say it's a relation. To go that step farther to say it's a function, you have to have only one output for each unique input. All right, so the idea is we can do that with a table, looking to see if we repeat any of those input values. And then I'll show you in a graph is to check to make sure that you are passing the vertical line test. So the vertical line test, if it passes the vertical line test, then it is a function. To go to the one-to-one function, so a special type of function, is it has to also pass the horizontal line test. All right, and so this is where, if you remember when I told you guys it's okay to repeat output values, it can still be a function, right? To be a one-to-one function, you cannot have any repeats in the outputs either, right? So obviously, we can't have any repeats in my x values or inputs, right? That would make it a relation, not a function. But to go that step farther to say that it is a one-to-one function, there's no repeats allowed in the output or y values. So that's where the horizontal line test will come in, all right? We'll do that here in a moment. So let's first evaluate f of 2 on this parabola. So I go to an x value of 2, All right, so my x value of 2, and my function is right there at that point, 2 comma 1. So when you write the notation for this, f of 2 equals that output value of 1. Let's try f of negative 1. Same idea here, right? I go to my x value of negative 1, and my function hits there when my x is negative 1, which is a positive 4 for the y value. So that's going to be f of negative 1 equals 4. That's how you evaluate from a graph. Let's look at this last example, looking at using the vertical line test to see if we have a function. And then if we do have a function, let's use the horizontal line test to see if the function is one-to-one. All right, so this function in letter A, if I use my my pen and flip it to be a vertical line, I never hit more than 1 point on a vertical line. So this is a function. Right, and you don't need to know this, but it crosses 1, 2, 3 times. So this is actually a cubic function. This one in letter B, let me go back. Let's do that last. So letter B, if I do my vertical line test, yes, this is a function as well. All right, and you can see this hopefully is a linear function. All right, it's a line. And then this last one, C, right, this circle fails the vertical line test. You could draw a vertical line anywhere you wanted, except for the ends, and you would hit more than once. So there's an example of it failing the vertical line test. It hits 2 points. It hits 1 here and hits 1 there. So in this case, this is going to be a relation. All right, now the last thing is, are any of these functions one-to-one? So if I go to my first two, which are the only ones that were functions, you'll see that there are many places, but this fails the vertical line test there. It hits 3 different times on that, horizontal line test. They already passed the vertical line test. This is going to fail the horizontal line test, so it's not one-to-one. It's still a function, right? But it's not one-to-one. And then with this one, this linear function actually does pass the horizontal line test. It never has a horizontal line that hits more than 1 point. So yes, this one is one-to-one. All right, and so that's it for this lesson. Don't forget to try the practice problems, the at your board problems. There are a few exit ticket questions based on these. And then ultimately, don't forget to practice those Delta Math links. Good luck.